Welcome back, everyone, to the deep dive. We got a great question from a listener who's just starting to code.
Oh, yeah.
They're wondering, should they focus on learning different programming languages first, or should they dive right into learning algorithms?
Mm.
They specifically mentioned AlgoCademy, that platform. It's got them thinking, are algorithms something I should be tackling as a beginner?
That is a question I hear so often, and for good reason. I
Yeah.
mean, it really gets to the heart of what software development is.
Right.
It's like, okay, programming languages, those are like the words and the grammar that we use to talk to computers.
hmm
But algorithms, those are the thoughts behind the words,
Oh, interesting.
the logic, the steps we take to solve a problem.
Okay, so I'm trying to picture this. So, I might know every single word in the dictionary,
Right.
but if I don't get grammar,
Exactly.
I can't write a good sentence.
You can't structure those words in a way that makes sense, and that's exactly what algorithms help you do. They help you structure your code, your program, in a way that's elegant, efficient, and it actually works.
Okay, that's a great analogy. So, let's say someone's just starting out, like our listener. Why should algorithms even be on their radar this early on?
Well, you know what? Learning algorithms can actually make learning programming languages even easier.
Oh, really?
I want you to think about building a house, right? You wouldn't just start throwing bricks together, would you?
Hopefully not.
You'd start with a blueprint. And algorithms are the blueprint for your code.
Oh,
They provide the structure, the plan. So it's not just about having this vague idea of what you want to build.
yeah.
It's about having this precise, step-by-step plan to follow.
So, I'm getting that algorithms are about bringing this logical thinking into coding.
Yes.
Is it safe to say that this logical step-by-step thinking, is that something that you can apply to, any coding language?
Yeah. Absolutely. The beauty of algorithms is that they're not tied to a specific language. It's a way of thinking, a problem-solving mindset that you can apply to anything you're coding, whether you're debugging or you're designing new features or even just trying to understand someone else's code.
I like that.
It's a universal skill.
Yeah. Yeah. It's like honing a transferable skill that applies across the board.
Exactly. And on top of that, there are also the practical benefits, the things you see in your code.
Hmm.
A good algorithm can make your software run faster. It can use less memory. It can even handle more users. That's all crucial stuff, even for small projects, really.
Oh, for sure. That actually reminds me of this time I was working on this personal project. I won't bore you with the details,
No, tell me.
but it involved sorting through tons and tons of data.
Okay, yeah.
My initial code, oh man, it was so slow. It was like watching paint dry.
Yeah.
But then I finally learned about this algorithm, you probably know it, merge sort.
Oh, the classic merge sort.
And you know what? It just sped things up like crazy. It was like night and day. And I finally had this aha moment where I was like, this is the power of algorithms.
It's such a good feeling when you see it click like that,
hmm
right? And that's why I think, the sooner you get comfortable with algorithms, the better your code is going to be right from the start.
Yeah.
And even as a beginner, you're already writing more efficient, scalable programs just because you have those tools.
All right. So we're on the same page that algorithms are important. But can we address the elephant in the room? What about things like big O notation, time complexity, space complexity? I mean, that stuff can sound intimidating, especially for someone just starting out.
Right, yeah, it can seem like a whole other language.
Yeah.
But really, don't let the jargon scare you off. It's
hmm
not as complicated as it sounds. Think of time complexity as like, how long does it take your program to run?
Okay.
And as the amount of data you're working with grows, does that time also grow out of control?
Okay, so if my code just gets super slow when I have a lot of data, that's a sign of bad time complexity.
Exactly. And big O notation, it just gives you a shorthand way to describe that.
Okay.
And space complexity. Same idea, but with memory.
Gotcha.
How much memory does your program gobble up as the data gets bigger? And big O helps you compare different algorithms side by side, so you can choose the most efficient one for the task.
So it's like I can compare different cars based on their fuel efficiency, even if I don't know exactly how the engine works.
Yes, exactly. You don't have to be a mechanic. All right, so we talked about time and space complexity. That's a good start.
Yeah.
But let's get down to the nitty-gritty. What are some of the common types of algorithms that you especially as a beginner, should be aware of?
Well, there are a few essential types that are really like the building blocks you'll see again and again.
Okay.
So you got your sorting algorithms, your searching algorithms, and then you start getting into things like graph algorithms and dynamic programming. Okay, let's unpack those a bit. What's the deal with these sorting algorithms? What are they all about?
Well, just think about how often we need to sort things in life, and especially in programming. I mean, a list of names, numbers, search results, you name it. Sorting algorithms are all about how to put those things in order, but doing it efficiently.
I see. But like most programming languages already have a sort function built in, right? So why would I need to understand the algorithm behind it?
Ah, that's where it gets interesting, because there are actually lots of different ways to sort data. And some of them are way faster than others, especially when you start dealing with massive amounts of data.
So knowing how they work under the hood helps you pick the right tool for the job depending on what you're sorting.
Yeah. Like, let's take a super simple example, the bubble sort. It's easy to understand, but it can be really slow for large lists.
Right.
Then you've got something like merge sort, which is much faster for those big data sets, but a little trickier to wrap your head around at first.
So it's kind of like choosing between a bicycle and a sports car. Like, a bicycle is fine for short trips around the neighborhood, but if I want to go cross country, I'm going to need something a lot more powerful.
I love that analogy.
Hmm.
All right, now what about searching algorithms? These guys are all about finding a specific item within a data set. So like, imagine you're looking for someone's phone number in a giant phone book.
Okay, yeah.
The most basic search you could do is called a linear search,
Okay.
which is basically just looking through the phone book page by page until you find the name you're looking for. It works, but it can be super slow, especially if the phone book is massive.
Right, so there's got to be a faster way, right?
There is. If your data is already sorted, you can use something called binary search, which is crazy efficient. Think of it like instead of going page by page, you open the phone book right in the middle.
Okay.
If the name you want is alphabetically before that, you get rid of the second half of the book. And you keep doing that, having your search space each time.
So it's like constantly narrowing down the possibilities until you zero in on the right one. I'm starting to see how knowing these algorithms doesn't just make my code faster, but also helps me understand these trade-offs between different approaches.
Absolutely. And that's a key part of becoming a good programmer, making those smart choices about which approach to use. Now let's touch briefly on graph algorithms. Have you ever used like a mapping app to find the shortest route between two places?
Oh, yeah, all the time.
Well, guess what? Those apps are using graph algorithms to figure out the best route, taking into account things like traffic, road closures, all that good stuff.
That's how they do that.
Yep. Graph algorithms are all about navigating relationships and connections between things. Whether it's cities on a map or people in a social network, they help us find the paths and connections that matter.
Okay, and now this dynamic programming, I think we need a bit more on this one.
All right, dynamic programming.
It sounds a little, well, dynamic. What is that about?
It is dynamic.
Yeah.
Okay, so imagine you're climbing a staircase. Instead of taking each step individually, you can use the steps you've already climbed to help you reach the next one.
Right, right.
Dynamic programming in code, it kind of does something similar. It stores and reuses solutions to smaller problems to help solve the big problem. So you're not wasting time recomputing the same thing over and over.
So it's about being clever, not repeating unnecessary work.
Exactly. It's all about optimization, finding the most efficient way to get to that solution. So we've talked about a bunch of different types of algorithms, but the question is, how do you actually go about learning them? And that's where platforms like Algo Academy that you mentioned can be really helpful, especially for beginners.
Yeah, I've heard a lot of good things about Algo Academy and similar platforms. What makes them so effective for learning algorithms?
Well, for one, they usually offer a very structured learning path, so you're not just thrown into the deep end.
Right.
They often start with the basics and then gradually introduce more complex concepts so you don't feel overwhelmed. And what's even better is that many of them have these interactive coding environments built right in.
Um,
So you're not just reading about algorithms, you're actually writing code, testing things out, and seeing how these algorithms work in action.
So it's learning by doing, actually getting your hands dirty with the code.
Exactly. And the real-time feedback you get on these platforms is so valuable. Like you can catch errors quickly, you can learn from your mistakes. It's almost like having a virtual coding coach right there with you.
Yeah, it's like that instant gratification. You can see if your code works or not and get hints if you're stuck.
Exactly. And another thing that's really cool is that they often have these curated problem sets and coding challenges, and many of them are designed to mimic real-world scenarios. Even those dreaded technical interviews that everyone's so afraid of.
Oh, yeah, those interviews.
I know, right?
I've heard some horror stories about algorithm-heavy questions.
Oh, they can be tough. But imagine going into those interviews feeling confident and prepared because you've already practiced on these platforms. You've seen these types of problems before. That can give you a huge advantage.
So it's like a boot camp for your brain,
Exactly.
getting you ready to tackle whatever algorithm challenge comes your way.
And let's not forget the power of community, right?
Mm-hmm.
Many of these platforms have forums, they have discussion groups where you can connect with other learners, ask questions, you can share tips, you can get support. It's like having a virtual study group.
Yeah.
And that can be incredibly motivating, knowing you're not alone in this journey.
Okay, so we've talked about why algorithms are important, some of the key types, and how to start learning them. But let's be honest, there are some misconceptions out there that might make someone hesitate to dive in.
Yeah.
For example, do you need to be a math genius to understand algorithms?
Yeah, that's a big one, right? Like, you got to be some kind of super brainy math whiz to even get started with algorithms.
That's such a common misconception, but it's not really true.
Okay, good.
While some advanced algorithms, yeah, they do involve complex math, the fundamental concepts, the core ideas behind them are really rooted in logic and problem solving. And that's something that anyone can learn. So it's less about being a human calculator and more about thinking clearly and systematically breaking down problems into smaller steps.
Exactly. And another myth I hear a lot is that algorithms are only for competitive programming or for those who want to work at like Google or Facebook.
Yeah. Yeah, it's like this elite skill for the coding superstars,
Right.
not for us mere mortals.
But while algorithms are definitely important in those fields, they're also essential for any kind of software development, really.
Mm.
Whether you're building a website, a mobile app, even just writing scripts to automate your tasks.
Mhm.
Understanding algorithms can make your code more efficient, more scalable, more maintainable.
So it's not about being the fastest coder in the West. It's about writing good, solid code that solves problems effectively.
Exactly. And speaking of misconceptions, another one that comes up a lot is this idea that you can just rely on libraries and frameworks and you never actually have to learn the algorithms yourself.
Right, because there's so much code out there that already does all the heavy lifting for us.
Yes. And we should absolutely use those tools. They are fantastic. They save us so much time and effort. But here's the thing. Understanding the algorithms behind those tools makes you a better developer.
So I can drive a car without knowing how the engine works.
Exactly.
But understanding the mechanics under the hood makes me a much better driver.
Yes. It helps you choose the right tools for the job, troubleshoot problems more effectively. You can even write your own custom solutions when you need to, if you understand how the underlying algorithms work.
I get it. It's like I don't need to build a computer from scratch, but understanding those basic components helps me make smart decisions about which computer to buy and how to use it effectively.
Perfect analogy. Now, I think the biggest misconception of all, the one that holds so many people back, is this idea that algorithms are just too hard for beginners.
Yeah. Yeah, it's easy to get intimidated by all this talk about complex algorithms and fancy notation.
Right. And, it's okay to feel a little overwhelmed at first. It's a new field. But the truth is, anyone can learn algorithms. Anyone can learn this stuff with the right approach and the right resources. Start with the basics, build a solid foundation, and don't be afraid to ask questions, to seek help.
And remember, everyone learns at their own pace. It's about progress, not perfection.
Exactly. The key is to stay curious, keep practicing, and celebrate your wins along the way. Now, remember your initial question, should you focus on languages first or algorithms?
Yes, that's right. Yeah, we got a little sidetracked there with all this amazing algorithm talk.
We did. We went down the rabbit hole. But it's all connected. It's all good stuff. And I think what's interesting is that learning algorithms can actually accelerate your language learning.
Oh, how so?
Because when you understand algorithms, you start seeing these underlying patterns, this structure behind programming problems.
Okay.
And it doesn't matter which specific language you're using, it's like you're learning the grammar rules that apply to any language,
Yeah.
not just memorizing the vocabulary of one.
Oh, so it's like learning how to construct a sentence in any language, even if I don't know all the words yet.
Exactly. And then when you do pick up a new language, you can apply those algorithm skills right away. And it just makes the learning process so much smoother and faster.
Wow, so it's like having a secret weapon, a decoder ring for any programming language I encounter. That's pretty awesome. And I'm guessing this can really come in handy when it comes to, career stuff, job hunting. Because a lot of tech companies, especially the big ones, they really place a lot of emphasis on algorithms during their interview process.
Oh, absolutely. Having a strong grasp of algorithms is one of the most sought-after skills by tech companies, especially, those big names everyone wants to work for.
Yeah, yeah. Those technical interviews, they have a reputation for being pretty intense.
They do, but think about it. If you walk into that interview and you've already got a solid understanding of algorithms under your belt, you're going to approach those questions with so much more confidence. And that's going to make a huge impression.
So it's not just about writing better code, it's about opening doors to these incredible career opportunities.
Exactly. And at the end of the day, learning algorithms is really an investment in yourself, in your growth as a developer. It's about expanding your skill set, pushing your boundaries.
It's like leveling up as a coder.
Exactly.
Yeah.
So to wrap things up, if you're still on the fence about whether you should dive into algorithms, especially if you're just starting out, my advice is go for it. It might seem daunting at first, but I promise you the rewards are well worth the effort.
Yeah, and I think we've busted some myths today.
I hope so.
Algorithms aren't just for the coding elite. They're for anyone who wants to write better code, solve problems more efficiently, and really unlock their potential as a developer. So I guess the answer to our listener's question is, it's not really about choosing one over the other. It's
Right.
about recognizing that algorithms and languages, they actually work together.
Absolutely.
They complement each other.
They do.
And the sooner you start exploring both, the better off you'll be.
I completely agree. And you know what? Here's something to think about. Just look around you at all the technology that we use every day. Search engines, social media, online shopping, all of it.
Yeah.
Algorithms are working behind the scenes, quietly powering all of those systems, shaping our digital world in so many ways.
Wow. I never really thought about it that way, but it's true. It's like this hidden layer of logic that's constantly influencing our experiences.
It is. And as you start learning about algorithms, you're going to gain this deeper understanding of how all these things work. And who knows, maybe it will inspire you to create your own algorithms to solve new problems and makes the world even better.
That's pretty inspiring. Well, folks, that wraps up our deep dive into the world of algorithms for today. We hope this has given you a better understanding of what they are, why they matter, and how to get started.
Yes, and remember, it all starts with taking that first step.
Be curious
Keep practicing.
and enjoy the journey.
Happy coding, everyone.
BB coding.